Hello, Block 4, 7th grade math. This is Mr. Sisson. Today I will be going over the examples for Lesson 7 in our workbook. This can be found on page 26, 27, and 28 of the workbook. This is our first lesson of Topic B. So let's begin. Our objective for this lesson is I can find and interpret the constant of proportionality within the context of problems. Let's look at the first example on page 26. National Forest deer population in danger? Wildlife conservationists are concerned that the deer population might not be constant across the national forest. The scientists found that there were 146 deer in a 116 square mile area of the forest. Let's go ahead and underline that information. In another part of the forest, conservationists counted 117 deer in a 13 square mile area. We'll underline that information as well. Yet a third conservationist counted 216 deer in a 24 square mile plot of the forest. Okay, so we'll go ahead and once again underline that information. Do conservationists need to be worried? So first, let's talk a little bit about Part A. And why do you think it matters if the deer population is not constant in a certain area of the national forest? Go ahead and pause the video right now and brainstorm some ideas for this. Okay, so some reasons why I think it would matter would be food supply in a certain area, overpopulation, and potential damage to land. Okay, my images are a little too big here, so let's go ahead and make those smaller. Okay. So let's go on to Part B. And what is the population density of deer per square mile? So in order for us to think about this, we have our information we underlined in our problem, and we're going to take that information and we're going to make a chart. So in Part B, I want you to make a 3-column chart . And in the first column, I want you to label that square miles. And in parentheses, this is going to be our X. The number of deer will be our Y. And in our third column, this will be our unit rate and our constant of proportionality. Okay, so going back to our underlined information, we know that there are 144 deer in 16 square miles. There are 117 deer in 13 square miles. And In our last column, we have 24 square miles with 216 deers. So if you remember back to a previous lesson about constant and proportionality, we talked about this equation, y equals k times x. So if we were looking for a constant of proportionality, we would find that y divided by x equals k. So to do this problem, we would take 144 divided by 16, which equals 9. 117 divided by 13 also equals 9. And 216 divided by 24 also gives us 9. So the unit rate of deer per 1 square mile is 9. Our constant of proportionality, k equals 9. And the meaning of this in this problem there are 9 deer for every 1 square mile of forest. Now we've completed question B, part B of question 1, and now let's move on to part C. I've included the chart in here for you to continue using, and question C is asking, use the unit rate of deer population of deer per square mile, or y over x, to determine how many deer there are for every 207 square miles. So we'll go ahead and we'll underline that so we know 207 square miles. And if we were to take a look at this, square miles is x, and we know our k, taking our equation, y equals k times x. We substitute in for this, and we know y equals 9 times 207, which gives us 1,863. There are 1,863 deer for every 200 square miles. Let's take a look at one other example. Use the unit rate to determine the number of square miles in which you would find 486 deer. So let's take a look at our equation again. Y equals k times x. We know y is equal to 486. (486) is equal to 9. And since we're looking for square miles, we don't know what x is. So our next step is get x by itself. Take 486 divided by 9, which equals x, which gives us 54 square miles. There, in 54 square miles, you would find 486 deer. So be ready to talk in class Do conservationists need to be worried? Make sure you're able to support your answer with mathematical reasoning about the rate and unit rate. Stay tuned for the second video, which I'll go over example number 2 and example number 3.